Hello and welcome to Tech of the Day. Today we're going to talk about develop solutions that use Azure Table Storage. In this module, we will talk about Azure Table Storage, authorization in Azure Storage, table service REST API programming interface. So using table service with REST. Let's go. As we already discussed, we're going to talk about Azure Table Storage, authorization in Azure Storage, and table service REST API. First, table Azure Table Storage. In this lesson, we will learn about table storage in Azure, choosing Azure Storage or Cosmos DB, guidelines for table design, read efficient table design, write efficient table design. Azure Table Storage is a service that stores structured NoSQL data in cloud, providing a key attribute store with a schemaless design. Because table storage is schemaless, it's easy to adapt your data as the needs of your application evolve. Access to table storage data is fast and cost effective for many types of applications and is typically lower in cost than traditional SQL for similar volume of data. So it's cheap because it's NoSQL and fast to access because it is a key attribute store. To know more about table storage, what is table storage? It stores semi-structured data that's highly available, create apps that require a flexible data schema, perform OData-based queries, create massively scalable apps, use JSON to serialize data. It stores petabytes of structured data, supports flexible data schema made for enterprises and designed for developers. And why you can trust table storage? Because Microsoft invests more than $1 billion annually on cybersecurity research and development. They employ more than 3,500 security experts completely dedicated to your data security and privacy. Azure has more compliance certifications than any other cloud provider. So that's why you should use Azure Table Storage. Table hierarchy. You see here table hierarchy. A table storage contains following components like accounts, table, entity, and properties. Accounts have all access to Azure storage is done through the a storage account. So you need to have an account. Then you have a table. A table is a collection of entities. Table don't enforce a schema on entities, which means that a single table can contain entities that have different sets of properties. So here you see you might have customers and orders. An entity is a set of properties. The diagram depicts the resource hierarchy for an Azure Table Storage resource, including the parent account and child entities. It shows the relationship of parent account, that is the storage account, store and tables, customers and orders, and the entities such as name and email. It's similar to a database row. An entity in Azure Storage can be up to 1 megabyte in size. An entity in Azure Cosmos DB can be up to 2 megabyte in size. Properties. A property is a name-value pair. Each entity can include up to 252 properties to store data. Each entity also has 3 system properties that specify a partition key, a row key, and a timestamp. Entities with the same partition key can be queried more quickly and inserted, updated in atomic operations. An entity's row key is its unique identifier within the partition. Table storage structure. Let's now understand the structure of the table storage. The data in Azure table storage does not conform to a specific schema. It is very common to see data stored within the same table with different combinations of fields and values. The data in Azure table storage is also physically partitioned by using partition key field. This means that the data with the same partition key can be queried together in an efficient manner. Cross-partition queries, while sometimes unavoidable, do incur an additional performance cost when they are run. In this example, the table has few records of students in elementary school, splits across two partition key values. These records have different combination of fields. The records are illustrated as a table even though the underlying storage mechanism is not relational in nature. So you have two different approaches or options storage choices in Azure Table Storage and Azure Cosmos DB. When you have a key value structured storage data, you can store it in Azure Table Storage or Azure Cosmos DB. So let's discuss the variations between each service. Choosing Azure Storage or Cosmos DB. Azure Table Storage and Azure Cosmos DB Table API share the same table data model and expose the same create, read, update, and query operations through their SDKs. But they have some difference. Latency fast, but no upper bounds on latency for Azure Table Storage, whereas for Azure Cosmos DB Table API, single-digit millisecond latency for reads and writes, backed with less than 10 millisecond latency reads and less than 15 millisecond latency writes at the 99th percentile at any scale anywhere in the world. That is too big. Throughput. Variable throughput model tables have a scalability limit of 20,000 operations per second, whereas Azure Cosmos DB is highly scalable with dedicated reserved throughput per table that's backed by SLAs. Accounts have no upper limit on throughput and support more than 10 million operations per table. Then global distribution. Single region with one optional readable secondary data read region for high availability. You can't initiate a failover. And then for Cosmos DB, turnkey global distribution from 1 to 30 plus regions, support for automatic and manual failovers at any time, anywhere in the world. Azure Cosmos DB Table API. So next in the same line are indexing. Only primary index on partition key and row key, no secondary indexes. Whereas for Azure Cosmos DB, automatic and complete indexing on all properties, no index management. So, and for execution uses indexes for primary key and scans. Otherwise, queries can take advantage of automatic indexing on properties for fast queries time. So you see the difference here in indexing and queries. And then consistency. Strong within primary region, eventual within secondary region. For Azure Cosmos DB, 5 well-defined consistencies labeled to trade off availability, latency, throughput, and consistency based on your application needs. Efficient design table. So design for querying in read-heavy applications. Specify both partition key and row key in your queries. Consider denormalizing your data. Use compound key values and use query projection. So how can you design efficient table? Keep these five things in your mind. Design for querying in read-heavy applications. When you're designing your table, think about your queries, especially the latency-sensitive ones that you will execute before you think about how you will update your entities. This typically results in an efficient and performant solution. And you specify both partition key and row key in your queries. Point queries such as these are most efficient and table service queries. Consider storing duplicate copies of entities. Table storage inexpensive, so consider storing the same entity multiple times with different keys to enable more efficient queries. Then consider denormalizing your data. Table storage is inexpensive, so consider denormalizing your data. For example, store summary entity so that queries for aggregate data only needs to access a single entity. Use compound key values. The only key you have are partition key and row key. For example, you use compound key values to enable alternate keyed access paths to entities. Use query projection. That means you can reduce amount of data you transfer over the network by using queries that select just the fields you need. The first one was read efficient. Now we want to write efficient table design. So it needs to follow four principles. Do not create hot partitions, avoid spikes in traffic, and don't necessarily create a separate table for each type of entity. Consider the maximum throughput that you must achieve. So these four things: avoid hot partitions. You choose keys that enable you to spread your request across multiple partitions at any point in time. Avoid spikes in traffic. Smooth traffic over a reasonable period of time and avoid spikes in traffic. Don't necessarily create separate table for each type of entity. When you require atomic transactions across entity types, you can store these multiple entity types in the same partition in the same table. Consider the maximum throughput that you can achieve or you must achieve. You must be aware of the scalability targets for the table service and ensure that your design will not cause you to exceed them. Normalization versus denormalization. When you design data for a NoSQL system, you must decide between normalized and a denormalized data structure. Update operations update the entire document, not specific field or parts of the document. When updating the entire document, risks and benefits are associated with minimizing or maximizing the number of documents in your data structure. So, normalization, denormalization. Denormalized documents can be expensive to update. Denormalization has benefits for read operations, but you must weigh these benefits against the cost. For write operations, denormalization might require fanning out update operations. Normalization might require chaining a series of requests to resolve relationships. In this example, the normalized JavaScript JSON objects are smaller and easier to update with strong write performance. Conversely, the normalized documents can potentially, but no, not always, require an extensive query to retrieve. The denormalized document is more expensive to update because the indexer must index additional fields. However, the denormalized document is single document and can therefore be queried in a single fixed performance request. So normalized and denormalized objects have their own benefits. So normalized is optimized for write operations and denormalized data is optimized for read operations. Lesson 2 is authorization in Azure storage. In this lesson we will learn authorizing with shared key, establishing a stored access policy, course support for Azure storage service. Container permissions. There are three levels of container access: full public read access for blobs only, no public read access. Full public read access means enumerate container blobs, read individual blobs, cannot enumerate containers. Public read access for blobs only, which gives access to read individual blobs. No public read access, no access to blobs, containers, or enumerating contents. We will learn more about these permissions when we will do in reality hands-on storage. Authorization. Every request made against a storage service must be authorized unless the request is for a blob or container resource that has been made available for public or signed access. One option for authorizing a request is by using shared key. Use the shared key authorization scheme to make requests against the table service by using REST API. Shared key authorization for the table service in version 2009-9019 and later uses the same signature string as in previous version of the table service. So you have different types of authorization. One of them is shared key, which is mostly used for storage services. Now let's know more about shared key, shared access signature. A shared access signature SAS token is a URI that grants access to protected container blob, queue, or table for a specific time interval. Allows client application to access a resource without using the storage account key. Should only be used with secure HTTPS requests. Can be generated with the components like start time, expiry time, permission label, which includes read, write, delete, list, or none. Stored access policies, which has granular control over a set of shared access signatures. Signature lifetime and permissions are stored in policy as opposed to the URL. Container queue or table can have up to 5 stored access policies. How to establish a stored access policy? A stored access policy provides an additional level of control over service level shared access control (SAS). Sorry, shared access signatures (SAS). On the server side, establishing a stored access policy server to group shared access signatures and to provide additional restrictions for signature that are bound by the policy. You can use stored access policy to change the start time, expiration time, or permissions for a signature, or to revoke it after it has been used or issued. So you can establish some stored access policies which will automate your job after you have used them. Basically, this is used for that. Course support for Azure storage services. Beginning with the version in 2013, Azure Storage Services support cross-origin resource sharing, which is CORS for the blob, table, and queue services. The file service supports CORS since 2015. CORS is an HTTP feature that enables a web application running under one domain to access resources in another domain. Web browsers implement a security restrictions known as same origin policy that prevents a web page from calling APIs in a different domain. CORS provides a secure way to allow one domain or origin domain to call APIs in another domain. You can set different CORS rules individually for each of the storage services by calling set blob service properties, set file service properties, set queue service property, and set table service properties. You can set different CORS rules for individual storage service. Once you set the CORS rules for the service, then a properly authenticated request made against the service from a different domain will be evaluated to determine whether it is allowed according to the rules you have specified. Very good thing to use in your application. REST table service REST API. In this lesson, you will learn about table services, resources, query timeout and pagination, querying tables and entities, inserting and updating entities. Table service resources. This example shows the structure of a URL for a table service request. It shows how a table and individual entities are requested using a structure described in the first example URL and functions data table. You see here the endpoints contains the name of your account, then table.core.windows.net that slash table. To get it, to put same you use put for to post you use the table to post and you delete to put you put table services modifying resources. Here you see a partition key mid and then you see the name of it. So to put a request you send the name of the table which is confield district table.core.windows.net slash students which is a an object and apple you send some data in there and with that you send a put request. Table service resources queries using OData. Same way you can query OData with account.table.core.windows.net slash table and the same way to get it you send get table. To query the table you send the get slash table with the query string filter equals to blah blah queries expression, and to delete it you simple say slash delete slash table. To insert you say put slash table. Very simple. Table services resource queries using OData. To continue from the previous slide, in this example, to retrieve entity, the first example explains retrieving a specific entity from the table. Remember, you can't retrieve an entity unless you have both the rookie and the partition values. They are both part of the composite key. So you need to send table partition key and rookie. Second example is for filtering. The second in this example explains the filtering by using OData syntax where you send the filter grade GE3. And in third one you have projection where the third example and uses standard OData syntax for projection. And you say table function question mark select equals to first name and last name, which is saying what to select from there. query timeout and pagination. The table service supports the following two query operations. The query tables operation returns the list of tables within the specified storage count. The list of tables may be filtered according to criteria specified on the request. The query entities operation returns a set of entities from the specified table. Query results may be filtered according to criteria specified on the request. A query against the table service may return a maximum of 1,000 items at one time and may execute for a maximum of 5 seconds. If the result set contains more than 1,000 items, if the query did not complete within 5 seconds, or if the query crosses the partition boundary, the response includes header that provide the developer with the continuation tokens to use to resume the query at the next item in the result set. So you send like this, and then in the next query you get the another one. Continuation token headers may be returned for query table operation or a query entity operation. To retrieve the continuation token and execute a subsequent query to return the next page of results, first inspect the response header for continuation tokens. If there are no headers or header value are null, there are no additional entities to return. So if you don't have any continuation header, that means there are no value to return. Accessing storage table with .NET. So to do that, you must use a cloud storage account class that you use for storage, Azure storage blobs and queues to access the table service. So here you say account.create cloud table client. Then you get the table reference with the name of the table, and then await table.create if not exist async, where you just say create it. It doesn't exist. So create if not exist member, you send a table name, you check if it exists. If it does not exist, you say create it. The cloud table class has a special helper method create if not exist that will check the existence of a table with name and properties that you specify. If the table doesn't already exist, you will create the table on your behalf. So implementing table entity class, to insert or query an entity, the easiest way is to implement a POCO class that inherits from table entities. This class contains properties or click for required fields such as row key partition. If you don't know what is POCO class, it's old way of um, saying where plain old CLR object. A plain old CLR object is a class which doesn't depend on any framework specified class. It is like any other normal .NET class. Due to this, they are called plain old CLR object. These classes or POCO classes implement only the domain business logic of the application. So here you see as well, yeah, this is the POCO class. And now to query a table, you can issue a new query by building a query using the table query.generate filter condition. You see here, you generate a new query using table.generate filter condition where partition key query comparison equals to $. So you set the query here, and then you, you You set the condition here, and then you query new query where condition is true, and then for each customer entity in table.execute query, and then here you write down the results. You might have many results here because the query was comparison if equals to day, and it might contains many. Inserting an entity, you can build an insert request for a new entity using table operation.insert static method. This method expects an object that inherits from the table entities class. Once you build the request, you can use the cloud table client.execute method to issue the request to the table service. So you see here, insert operation equals to table operation dot insert customer one, which we created here, and then table dot execute insert operation. The operation we just created, we need to execute it, so then it's inserted. Managing Azure Table storage while using .NET. We will do a lab for this class of lesson or video as well, as same as for other videos. We have lot of labs, and we will do all of them all together in once we finish the theoretical part, because this will require some action or some a lot of things actually to fix. So let's do it when it's done. So to review here what we did, we learned about Azure Table Storage, authorization in Azure Storage, table service REST API. Just to show you, okay, I don't have that open, so okay, let's continue then. So thank you for watching, and like, share, and subscribe. Please stay tuned for next videos because I'm gonna create labs for this, and these are the labs from Microsoft itself. So this is not something I'm going to invent or use, but I'm just going to use those labs and create videos over them and discuss those videos, those labs in those videos. So stay tuned, and thanks for watching. Bye.